Good evening, students. Am I audible and visible to all of you?
Yes, ma'am.
Okay. Have you done the question which we did in the last, which I gave to you in the last class? First of all, tell me how good was your exam, and is there any exam tomorrow also in your class?
Yes, ma'am. We have chemistry.
Chemistry. What is coming in the exam?
1 second, I will see the portions.
Okay.
We have structure of an atom, classification of elements and periodic properties, and chemical bonding.
Okay, that means this chapter is coming, right? So it's your
Yes.
term. I believe it's your term and exam or a quarterly exam. What do you call these exams as?
It's a midterm. We write it for 40 marks.
40 marks. Okay. So your school have not postponed because I just heard in news that UP government has made arrangement for school to be open today till late evening to watch the Chandrayaan landing on moon. Do you have such an announcement there in your state also?
Um, I'm not sure, ma'am.
Not sure. Okay.
Yeah.
And you are not excited to look at that or not? Not interested in that?
We are.
We are. Okay. Let's start. We'll see at 6:05 if we can get some communication and have a break of 5 minutes if you agree to see that.
Yes, ma'am.
Okay. Let's start. See, I gave you this question, and I believe because of your maybe the first and the last time that I'm giving you the leverage ki theek hai, you have not done the homework is still fine because we have to you were having a certain exams of other subject. Not let's do it quickly because again these are one of the questions. You have a paper tomorrow, may help you somewhere or the other. Can you predict the structure of SiF4? Take a minute and quickly predict it, taking it as if it has come in your exam. Okay, I will give you a hint. I thought it would be easy. You must have done it. I had a doubt about the rest of the two, or rest of the three rather. Basically, for two, rest of the three, there can be. See, SiF4, do you realize carbon and silicon belong to the same group of the periodic table? Ritika, do you know this fact?
Yes, ma'am.
So what should be the structure of silicon tetrafluoride? See, hydrogen, fluorine, chlorine, bromine, iodine, all of them. Hydrogen has one, it has got seven electrons in their valence shell. So what should happen? If carbon has 4 electron in valence shell, then silicon should also have 4 electrons in the valence shell. That means now can you predict the structure? I'm not asking you to draw it. Think about methane, CH4. What has happened? Remember, in the last class, we did all these structures. I'm coming back to that. It seems as if everything has become black and white. This you are blank. This was one of the structures we did it in detail. That methane will have sp3 hybridization. Any issues, Shweta?
I wasn't able to unmute, sorry.
Huh? I didn't get you
I wasn't able to unmute.
to hear.
No, I wasn't able to unmute. It showed some error.
Okay. Ritika, what about you?
Mom, I didn't know the answer, Mom.
Okay, you didn't understand this concept of hybridization?
I understood it, Mom.
I'm just asking all three of you or the other students also that should I repeat the concept of hybridization?
No, Mom, it's clear.
Okay. So when it is clear, so is the slide clear that what will be the structure of methane? Methane will have sp3 hybridization. Its shape will be tetrahedral. Is it clear to all of you now? Ananya, is it clear to you?
Yes, Mom.
Okay. Similarly, on the same basis, can we say that SiF4, silicon tetrafluoride, will also have the same structure? Because if I am asked to draw it, I will draw that silicon has 4 electron in its valence shell, like this. And then fluorine has got 7 electrons in the valence shell also, in its valence shell. Right? Same way, we will draw 4 fluorine and we will get a tetrahedral structure, SiF4. Bond angle 109.28 and sp3 hybridization. Now talking about NH2 minus. Anybody wants to answer that part? Okay, let me explain it to you. I was expecting it to be a bit difficult, so I wrote a detailed explanation for the same. I will just paste it on a separate sheet so that it's clear to all of you. See, the task was to know the structure or find the structure of NH2 minus 1. Whenever you have a cation or anion, that is the charged species, please find out how many electrons are there. Now, I believe this point is clear. The total valence electrons in nitrogen will be 5, right? Atomic number of nitrogen is 7 and it has 5 electrons. NH2 minus means it will have 6 electrons in the valence shell because they acquire negative charge by gaining an electron into it, right? So that means what is now NH2 having? NH2 minus is having, right? It has 2 NH bonds. That means it will have 2 bond pair and 2 lone pair of electrons, right? So this is 2 and 2. 2 lone pairs are there. That total, how many electron pairs? 4 electron pairs. So for 4 electron pairs, we know hybridization is sp3. The expected shape is tetrahedral, but because of the presence of 2 lone pair of electrons, it acquires bent shape. Is it clear? See, again, I'm repeat myself that I'm more interested in making you understand how to get this answer rather than just mugging it up. Whenever I'm repeating it again, whenever you have a cation or an anion, look for the number of electrons does it have in the valence shell? Here in this case, NH2 minus 1, it is very clear. Nitrogen was having 5 electrons. Because of one negative charge, it will have a total of 6 electrons instead of 5. 2 bond pair, 2 lone pair, sp3 bent shape. Is it clear to you, Ritika?
Yes, ma'am.
Okay. Now we had two more structures which were given to us. Similarly, on the same lines, NH4 plus, right? You can draw its structure. For the simplicity, we can say that ammonia, one of the other way of finding the structure of ions is that if you know the structure of corresponding neutral atom, we know ammonia. It was having sp3 hybridization, right? What it has done? In case of ammonium ion, it has lost its lone pair. So again, tetrahedral will be the shape and bond angle will be 109.28. Is it clear? Now moving to the C2H2, for that we must remember or we must know the concept of sigma and pi bonds. That in the last class we had a basic discussion and I gave you ethane, ethene and ethine to understand your knowledge or what do you understand by the concept. But unfortunately, for whatever reasons, the answers were not up to mark. So I believe we need to spend some 10-15 minutes or some time on that to understand whether or how and where sigma and pi bonds are formed. If Shweta can tell me, where can I expect a formation of a pi bond?
Yes, ma'am.
Between which orbitals? I'm making my question more specific. Name the orbitals which overlap to form the sigma bond and the pi bond.
Pi bond is p orbital.
Okay.
Sigma
Pi bond
bond
is
is s orbital.
okay. Any other answer? Ritika, do you want to add on to what Shweta said?
No, ma'am.
Okay. Okay. Then, Ananya, do you differ or agree with your classmates? This is what
Pi
Yeah.
bond is for p orbital. Sigma bond is like from S to P.
Okay. Okay. But I believe all of you are missing a major thing. Let me try and explain to you what is the correct answer. Before that, let us draw carbon in ground state. As I told you, every time we are going to draw only the valence shell, whether filled or not filled. So valence shell of carbon is having 2s and 2p, and 2s is having 2 electron, 2p was having these 2 electrons. Now, carbon in excited state will have 1 electron in 2s and 3 electron in 2p. Right? Now, my question is, that day also we were trying to find out the structure of these 3 compounds. The basic alkane, alkene and alkyne. The 3 categories of hydrocarbons. Right? One of them was C2H6. The other one given to you by me was C2H4. And the last one was C2H2. Right? Now, if you tell me that sigma is formed on S and pi is formed on P, how will you justify your answer? Which sigma, which 2s, which 2p? will be forming the bond. Is my question clear to all of you? How will you decide? For all of them, please understand my question clearly. For all these elements, for all these compounds, the common elements which are common to all three of them are carbon and hydrogen. But how do they differ in formation of a bond? So for that, let us understand few things. We will be doing sigma and pi bond in detail, and we will come back to it, and it will be you. But at the end of that, you will be enabled to answer this question of mine. See, remember this, that sigma is always head-on overlap on internuclear axis, right? So I will show you how it is done. If you imagine these two are the s orbital, we understand s is a non-directional orbital. So when they overlap it like this. Is it clear? Half of the area is overlapping. We say they are doing it on internuclear axis. Internuclear axis means the axis at which the carbon and hydrogen atoms are aligned. You can see on the screen, this is the internuclear axis, and if I draw this one, this is perpendicular to the nuclear axis. So this is the overlapping of, let me make it smaller, because S is assumingly spherical. We say they will be coming 2s of carbon and 1s of hydrogen. They will approach each other, and approximately they will be covering each other. Is it clear to all of you? At least please respond, students.
Yes, ma'am.
Yes.
Okay, thank you. Now, similarly, if we have px orbitals, the three dumbbells of px, right? One of them is at x-axis. If they are overlapping in this direction, what will happen? This is px of one carbon, this is px of other carbon, C2H6, right? What they will do? They will form a carbon-carbon bond. They are far apart. They will come closer, closer, and closer, right? Similarly, if there is s orbital, let's say this is s orbital of hydrogen, and this is p orbital of carbon. They are overlapping on the internuclear axis like this, right? So what they are doing? They are forming a sigma bond, right? So please remember that sigma bond is formed on the internuclear axis, and this is also known as head-on overlap, right? Now talking of pi bond, the pi bond, I will just show you the diagrammatic representation also. Are you able to see my screen?
Yes, ma'am.
Okay. See, we say S has no directional properties. So S and S, you can see here in this image that two S orbitals are overlapping, and the area of overlap is this one, right? Talking about the S and P, this is S and this is P of carbon. They are overlapping, and this is the area of overlap. Then the PP, only the internuclear axis will overlap, right? And they will overlap to give you the P orbit, the sigma bond, right? As I shown you with the help of two pens, that this will be the P overlap, right? Now talking about the pi bond. you can see in this image that pi bond is formed by the sideways overlapping of unhybridized. The keyword which I purposely did not I haven't kept here is the keyword is unhybridized, which means the orbital which has not taken part in the bond formation, right? So if I have to form a pi bond, those p orbitals will be out of hybridization. More importantly, they will, please look carefully, they can overlap. They are doing it perpendicular to the internuclear axis. So they can overlap only from the top and bottom. Why? The reason being, in between it, there will be a plane of a molecule where you have to have a sigma bonds, right? There will be a plane where there is a sigma bond. So they will be overlapping only sideways, something like this, which is depicted in a image here, right? So that is the key answer which I was looking from all of you. And more importantly, as you have seen that when we were doing the sigma bond formation, the overlap was smooth. They can move up to this extent, maybe 70% or 80%. But when you are doing only doing the sideways overlap, this and only this part, the upper and the lower body half or the orbital part are meeting or crossing each other. So sideways overlapping is taking place in the pi bond. They will of course have a lower area of overlap, right? So here are the some key points from what we have learned about the sigma and pi bonds, right? This we must remember. They're not asked in the exam, but indirectly you are asked to find the number of total sigma and pi bonds, right? And another thing which you are missing, in the exam you may be given the structure of C2H2, or you are asked to find the shape of C2H2 or C2H4 or C2H6. So as the point number 1 says, the strength of a bond depends on the extent of overlap. That is fair. More the overlap, stronger will be the bond. So in sigma bond, overlapping is higher as compared to the pi bond. That is what the point number 2 tells us, right? The third point is probably the newer one and most important one. Pi bond cannot exist alone, right? Pi bond has to be followed by to be preceded by rather sigma bond. Between any two atoms, there will always be a sigma bond. The rest of the bonds can be pi bonds, right? So pi bond will be found only in the compounds which are having a multiple bond. That is the last point telling us, right? That any two atoms, when you say talk about acetylene, you draw 3 lines indicating 3 bonds. The first one will be sigma, second will be pi, and third will be again pi, right? You cannot have a pi existing all alone. That is very important. You may be asked in the exam to write the difference between sigma and pi bonds also. Is it making sense to all of you? What was missing in your understanding? Am I able to clear those doubts? Please
Yes,
respond.
ma'am.
Okay, now Ritika, can you explain what differences between what do you understand by a pi bond?
I understood that the pi bond is formed only between two atoms and they do not have independent existence.
The most important part was it is formed by sideways overlapping of unhybridized p orbital. Is Shweta and Ananya also clear about what I mean by when I say unhybridized?
Yes, ma'am.
Okay. Now, this is the summary of what this you must remember. Differences between sigma and pi bond. The first point, it's just a recap of what we have done. Sigma is formed on the internuclear axis, whereas pi is formed by the sideways overlapping. Sigma can be formed by SS or SP overlap, whereas pi is formed by PP or PD. You can delete that PD part because that's a bit higher concept, not prescribed by CBSE. But it is important that we understand that it is formed by unhybridized p orbital sideways overlapping. Sigma, as I explained, is a strong and pi is a weak bond, right? Now, do they have a 1 electron cloud, 2 electron cloud? See, pi seems to have got, p orbital seems to have got this 2 electron clouds, right? This is one common cloud, but if it does a sideways overlapping, it seems to have a 2 clouds, one in this area and one in this area. That's the meaning of this one. And I'll come back to the last point that is also important. Free rotation across sigma bond is possible, but pi is not possible. Now for that, we need to understand first of all, the type of hybridization these 3 type of molecules have in carbon. First of all, C2H6. The name of this compound is ethane. And even if I forget to mention hydrogen at every free line, it's a way. The teacher or anybody can just remove those hydrogens also, because at times they clutter the thing. Before I take up this, if I draw oxygen like this, if I draw nitrogen like this, if I draw chlorine like this, now can you identify the bonds in it? Oxygen, beginning with you, Shweta. Classify the 2 bonds as sigma and pi. The first bond is, please remember, we said the first bond is always sigma. So the first bond is sigma. The second one is pi. Now, Ananya, you will tell me the name of the 3 bonds in terms of sigma and pi for nitrogen molecule.
Now, first bond is sigma.
Yeah,
Second is also sigma.
yeah.
Third is pi.
How do you say second is sigma? See, please remember what I said. First bond between any 2 atoms is sigma, rest are pi. Now, Shweta, Ananya, do you want to make correction in your answer?
Yes, ma'am. First is sigma. Second is pi. Third is also pi.
Correct. And for chlorine, now it is obvious the first bond will be sigma, right? So I'll come back to Ritika. Tell me the bonds in ethane. Label them as sigma and pi.
Ma'am, what was your question? I wasn't able to hear it properly.
See, I have drawn ethane on the left-hand corner of my screen. Can you identify all the CH bonds as sigma or pi bonds?
Yes, ma'am. It has 1 pi bond.
Where? I'm talking about the first compound, this one. This
Between
CH bond is
carbon.
this one is sigma or pi? The bond between this one. Let me label that as 1. What is this? Sigma or pi?
Sigma.
Okay. Then the second one is,
Sigma bond.
then see this carbon, the bond 3.
Pi bond.
Why pi, Ritika?
Because it is overlapping.
No, it is, okay. Please say, I'll just correct you. Please speak, Ritika.
Yes, ma'am.
Yeah, what it is overlapping?
Carbon bond.
See, if you look at the bond number 1, which you labeled it as sigma, Ritika, it was overlapping with carbon hydrogen. So why didn't you name it as pi? Dear students, just listen to me carefully. We said that the first bond between any two atoms will be sigma, right? Please pay attention now. Now, if I am talking about this carbon hydrogen bond, right? As I told you, I may miss hydrogen there. So this is the first bond between carbon and hydrogen. So it must be named as sigma bond. If I talk about the bond between carbon and chlorine, this one is the first bond. So it has to be named as a sigma bond. Talking about the bond between carbon and carbon, this is the first bond between them. So it will be named as sigma. But if I talk about the carbon-oxygen bond, this one is sigma, this one is pi. This bond is the first bond between two carbon atoms. So it will be sigma. This is the first bond between two carbon atoms. It will be sigma. This is the first bond between carbon and hydrogen. It will be sigma. This is the first bond between carbon and hydrogen. Again, sigma. Again, it has to be a sigma bond. Now, Ritika, can you please explain me what was your doubt?
Ma'am, I didn't ask any doubt.
Okay, but I felt your answer was not that appropriate, so I was just explaining. Okay, now, Ananya, can you tell me the sigma and pi bonds in case of ethene, the compound number 2?
For hydrogen and carbon, the first one will be sigma bond.
Between carbon and carbon, Ananya?
First will be sigma and second will be pi.
Correct. Now, if I talk about this compound, ethyne. Shweta, can you quickly help me with nomenclature in terms of sigma and pi?
For hydrogen and carbon, it will have sigma bond. And for the triple bond between carbon and carbon, it will have sigma bond, pi bond, and pi bond.
Right. Now today, now I believe you have understood the concept, because many a time they give you a big molecule, as I tried to give you in the center here, and ask you to count how many sigma and pi are there. Remember in the last class when I wanted to check your understanding, we started with the same thing, right? Now for ethane, we can count how many sigma, how many pi, right? It will be sigma, it will be sigma. I can say it has 6 CC sigma and, sorry, 6 CH sigma and 1 this CC sigma. So total of ethane has 7 sigma bonds. Ethene, if I'm incorrect, I might have counted incorrect, then please correct me, right? For ethene, we will say it has 1, 2, 3, 4, 5 sigma and 1 pi. In case of ethyne, we can see 3 sigma 2 pi. Is it clear now?
Yes, ma'am.
Okay. Now, can you predict whatever we have discussed till now on the basis of that the hybridization in each of the carbon atom of ethane, ethene, and ethyne? Both of them are going to have the identical. We have to find for one carbon atom, right? For that, you have to know for one carbon atom, how many sigma and how many pi bonds are there for one carbon atom, right? Similarly for ethene. Quickly start responding. Sigma, you have to tell me the number. Pi, you have to tell me the number. I think somebody in the last class answered it correctly. Similarly for this, sigma, how many? Pi, how many? Ethyne, how many sigma, how many pi per carbon atom? Carbon is tetravalent, we know that. It has got 4 electrons in its valence shell. I will start marking 1, 2, 3, and 4. Each carbon atom in case of ethane has 4 sigma and 0 pi bond. In case of ethene, it has got 1 sigma, 2 sigma, 3 sigma, 1 pi. So the number of sigma bonds will be 3 and that of pi bonds will be 1. In case of ethyne, 1 sigma, 2 sigma, 1 pi, 2 pi.
Excuse me,
It
mom.
will have, yeah,
Mom, when we're counting the sigma bonds, aren't we supposed to count both the carbons?
no. My question is specific. For one carbon atom, see, hybridization is a property of an atom. Carbon atom alone can undergo hybridization. So this is the time when I'm trying to explain you how you will get a different type of hybridization in ethane, ethene, and ethyne, right? I believe you are thinking that I'm asking for the total number of sigma and pi bonds. If I'm asking for, let me write it here, then I'll answer it further. It has got 2 sigma, 2 pi. The question is clear. I believe it was Ananya who was asking me. If I'm incorrect, please tell me. My question is specific for one carbon atom. Had I asked you the total number of sigma and pi bond. So in case of C2H6, you are correct. You would have told me that it has got 7 bonds and they are sigma, right? Is it clear now?
Yes, mom.
Okay, thank you. Now, similarly, if I count it for ethene, what we will do? We will have 1, 2, 3, 4, 5. Ethene we will have 5 sigma and 1 pi. Moving to C2H2, we will have 3 sigma and 1 pi. Is my counting correct? Quickly check and let me know. Okay, let's move on.
2 pi for carbon.
Oh, sorry. Correct. The last one has to be 2 pi. I'm so sorry. So now the question with which we started this discussion that how will I find the hybridization in case of, again, these three, C2H6, C2H4, and C2H2, ethane, ethene, and ethine. In all of them, the carbon, can I draw only the excited state now? Because ground state is already clear to us. This is the excited state of carbon. There are total of 4 electrons. Now, please tell, now can you predict the hybridization in case of each of them? For each carbon atom. For making you understand, we wrote it, each carbon has 4 sigma. Here, each carbon has 3 sigma 1 pi. Here, each carbon has 2 sigma 2 pi. Any predictions, or do you want to make any predictions on it?
One of the best thing which I would like definitely there every night actually.
Okay. What we have to remember? That pi bond is formed on unhybridized p. That means p orbital not participating in bond form in hybridization. Right? If I look at sigma, this first case 4 sigma, that means it requires all the orbitals of equal energy. All sigma bond must be having equal energy. So I will say that 1s and 3p will undergo hybridization to form 4 new sp3 hybrid orbitals, right? Now for C2H4, we understand it has to form 1 pi bond. That means we have to exclude one of the p orbitals from hybridization, because now we understand that pi is formed only on unhybridized p orbital. So hybridization in case of C2H4 will be sp2. Similarly, for ethine, we will say it will undergo sp hybridization, because for 2p, we need 2 pi bonds, we need 2 p orbitals which are not participating in bond formation. Making sense to all of you now?
Yes, ma'am.
So, if I can ask, till now, it was not, or I can just conclude it was not clear, but now you can tell me hybridization. And this is a key thing that please put it just, with a good colored highlighter in your notebooks, that pi bond will be formed only after the formation of sigma bond and on the unhybridized p orbital. And the answer to my question, how will you get different hybridization from the same electronic configuration, is this. You have to know the sigma and the pi bonds. And I believe we left this unnoticed here, and I said we will come back to it in later, right? Now, for that, we have to understand that sigma bond was formed in the plane of molecule, right? They have a 360 rotation at this axis. You can rotate anything. If you have a bond here, you can rotate it to 360-degree freely. But remember, if you go talk about the ethene, what is happening? The sigma bond, I'll tell you, it has a triangular planar shape. Why and how? We'll come back to it in a minute. Triangular planar, I can say that triangle is in the plane of my hand. I have drawn it like this. There will be 3 CH sigma bonds like this, right? Now what I say, we have understood p orbital is perpendicular to the plane of molecule. If this one is the plane of molecule, the pi bonds will be formed something like this. 1p here and 1p here in the plane of molecule. So what will happen? They can rotate only up to this extent. Why? Because it is the plane of molecule where we already have so many sigma electrons are there. So what they are going to do? They are going to repel each other. So therefore, the free rotation across pi bond is not possible. Is it clear now? That sigma bond, since it is parallel to the internuclear axis, they can rotate. But pi bond, when they start moving, they will move only to 180 degree, and after that there will be a sigma wala electrons plane. So they are going to repel them. Clear? Is it making sense to all of you? Clear? I'm just waiting for your response, students.
Yes, ma'am.
Okay. Now, coming to the shape of the molecules which are having sigma and pi bonds. Till now, you were understanding that only sigma bonds. Remember, whatever we did in the last class, just quickly flipping through them, whether bond pair load, according to VSCPR, right? You always considered a single bond between the atoms, right? There was no question of a double bond, whether distorted or a normal or a regular expected geometries. It was not a question. The pi bonds were not there. Now, the pi bonds and sigma bonds together will decide the geometry of the molecule. Let's see how they are going to do it. For that only, we did only one carbon atom hybridization. So now we know carbon, in case of C2H6, each carbon will undergo sp3 hybridization, right? So what will be the shape? You will draw the tetrahedral carbon, something like this, the first carbon, then the second carbon. Will be drawn something like this. This one is sp3 hybrid orbital. They will overlap and form a sigma. One hydrogen here, second one here, third one here, fourth, fifth, and sixth. And we say they extend and form the sigma bond. Making sense? Before that, let us see the shape of sp, sp3, sp2, and sp hybrid orbitals. If I talk about their shapes, beginning with sp3. S was spherical, which is, I will say, mathematically 25%, and contribution of P is 75%. In case of sp2, S is, let's say, 33%, and this is 67%. In case of sp, it is 50%, and it is also 50%. Now, what will be the shape of these hybrid orbitals? The sp hybrid orbital will have a 50% S and a 50% P character. So the shape of sp hybrid orbital will be something like this. Shape of sp2 hybridization will be a bit elongated because it has got more of a P character, right? So the shape of sp2 hybrid orbitals will and unhybridized P will always be, or we call it as pure P. Is it clear now? See, it is important, may not be given in the book as of now, may not be taken care so religiously in the syllabus as of now, but without it, you cannot do a hydrocarbon chapter, which is the second last or the last chapter of your book. If you are doing it here in a good manner, we will be benefited in the next chapter of hydrocarbon when we do hydrocarbons, right? So ideally, when you draw these structures, you have to be drawing sp3 hybrid orbitals in the same direction, something like this. This is one. This one is the second one. This one is we have the carbon at center. The third one is something like this. And the fourth one will be like this. For the other carbon atom, you will be showing it like this. One will be like this. The third one will be like this. And the fourth one will be like this. For hydrogen, we have to draw 1s. So 1s will be spherical. And we will name them as, this is sigma, 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 sigma. So if somebody asks you to draw the orbital picture of overlap, I believe you must not have been taught, but I will do it for only for sp3, sp2 and sp. I'll explain as it is given in the book, right? So is it clear to all of you? Should we move to sp2 or the structure of ethene? What happened to all of you? Are you there?
Yes, ma'am.
Okay. Then if we talk about ethene, C2H4, hybridization in it is sp2 because we have to delete one of the, or take away, not delete exactly, take away one of the carbon, one of the p orbitals from the hybridization. Now, can somebody predict the shape of sp2? We did it in VSCPR, or rather you did it in VSCPR. Two electron pair, linear. 3 electron pair, triangular, planar. Remember that? So what we have to do? We'll be saying this is triangular planar for one carbon. This one is for the other carbon atom, right? And there they are going to overlap with hydrogen, and here to form the 1, 2, 3, 4, 5 sigma bonds. Now talking about the pi bonds, the pi bond will be perpendicular to the plane of molecule. Triangular planar bond angle was 120 degree. So that means this bond angle will be of 120 degree. And the unhybridized p orbital will be parallel to, or sorry, perpendicular to the plane of molecule. That will be this one and this one, right? And with the help of dotted lines, the rule says you have to draw 3 dotted lines here and 3 dotted lines here. So the shape of the molecule will be triangular planar. Hybridization sp2, bond angle 120 degree, right? Is it clear or any doubt? Please say yes or no so that I can move to C2H2.
Yes, ma'am.
Okay, moving on to C2H2. As we said, it will C2H2 will have sp hybridization because it has to get a pi bond. So what they will do, this carbon and carbon will overlap. Then there will be one and one this and one this. it will form 2 sigma, right? 2 electron pair, maximum distance. What will be the bond angle? Bond angle will be, the shape will be linear and the bond angle will be 180, right? And here they will overlap with the HCH bond angle is 180 and the 2 unhybridized p orbitals will lie parallel to each other, one after the other. Like we place 2 hands like this, right? And this is for one carbon atom, there will be for another. That the first one will be overlapping with the first p, the second one will be overlapping with the second p, right? So again, what you have to do, you have to draw unhybridized p orbital at carbon atom. This one is 1. I will use another color to draw the second one just behind it like this. And the aage wala will, the first one will overlap. This will overlap with this from top and bottom. Similarly, this will overlap with this one from top and bottom. So the shape will be linear. I hope it is clear. And here, looking at these structures, you can understand the shape of a molecule depends only on the sigma bonds. In case of ethane, ethane was having 4 sigma bonds. 4 bonds means 4 electron pairs, that is tetrahedral as per VSEPR. In case of 3 electron points, we have triangular planar, and 2 electron points we are having linear, or at times I have read in the books, they call it as a circular also, right? So now we will come back to the question with which we left unanswered at the beginning of the class, that what will be the shape of C2H2. It can be said as cylindrical or linear, right? So that was all about the hybridization from my side. Moving on, let's do one more question, that find the number of sigma, total number of sigma and pi bonds in this compound. Quickly find the total number of sigma and pi bonds in this compound. Any answers from you?
Are there 9 sigma bonds and 5 pi bonds?
9 sigma and 5 pi.
1, 2, 3.
There are much more than, I think it was Shweta. It was
One
more
second,
than that.
no wait, I missed one. I missed the OH.
Okay,
I'll
just
do it once
draw
now.
them. See, what I expect is you need
11, 11 sigma bonds
to, okay,
and 5 pi bonds.
okay. I'll explain it to you. See, let's look at the second picture which I have drawn for you. It is a window to your future, what you should expect. This compound, you must have done it in class 10th. If somebody has to put a difficult paper in front of you, they will say, find all sigma and pi bonds in this compound. This compound is benzene. Benzene. If I draw every corner is having a carbon atom, that's a rule. So 1, 2, 3, 4, 5, then 6, right? Then to complete, and the formula of benzene is C6H6. What you have to do? You have to draw hexagon, then put one hydrogen at each carbon atom. 3, 4, 5, 6. Now you see that each of the carbon atom is having only 3 valencies. So what you have to do? You have to draw a double bond. Benzene as a rule has an alternate double bond, which is represented by the circle inside the hexagon. We'll come to it later when I talk about hydrocarbons. So the easiest way to give you a difficult question is find a sigma and pi bonds in benzene. We say there are total of 12 sigma and 3 pi bonds. Each carbon hydrogen has a sigma, sigma, sigma. You can count that. There will be total of 12 sigma, right? Whenever you are given a structure, you have to elaborate on it. When, let's say, I'm sure NH2 will not be asked in the exam, at least right now. But just giving you a vision of it, NH2 has to be redrawn, NH2. Then you will get 2 sigma. Good attempt, Shweta, I will say, but give it a thought. The COH, as you rightly pointed out for yourself, that there is a bond between oxygen and hydrogen. Now, talking about the COOH group at the bottom, it must be having certain bonds, no? There must be certain bonds between them. So, if I draw the missing bonds, there will be 1 sigma bond between oxygen and hydrogen. And for COOH, I need to redraw it like this. This will be C double bond O, OH. The purpose of giving you this question was not to have a doubt on it, but to make you understand what type of a question you can expect in your exam. Now, once you have simplified the structure in terms of sigma and pi bonds, you know that double bond means 1 sigma, 1 point. The life will become bit easier. Now you have to simply count them. Is it clear to you, Ritika and Ananya also?
Yes, ma'am.
So now can we quickly find out the number of pi bonds? I'm not interested in sigma now. Only the pi bonds. Tell me the count of pi bond in this particular compound. The first one. This compound.
Ma'am, we should find the pi bond or sigma bond for this, ma'am.
Pi. I'm asking for pi
Okay.
bonds, Ritika.
4.
You can see 1, 2, 3, 4. Or should there not be 5? I think I can see 5. See, for benzene ring, there have to be 3. So 1, 2, 3. The fourth one is here. And the fifth one is here. Isn't it? So you should be happy that you have done a bit. Isn't it? Am I correct or not?
Yes, ma'am.
Okay, good. So that means we have successfully cracked even a difficult question, which when exactly comes in the exam, maybe your final exam, I have given you the vision that this can be the most complex question. Now coming back to what we were doing in the last class, we decided to do the bond parameters, and in between we were stuck with this hybridization, right? So we clarified all the concepts of hybridization and sigma pi bonds, and then shape of the molecules which have more than one type of a bond in their structure. Where sigma and pi both are there, then we will consider only sigma bonds for finding the shape. But for finding the hybridization, both sigma and pi are important. I think in the last class we discussed about what is bond length. We have done it in the earlier classes also, periodic classification. Half of the distance between the nucleus of two bonded atoms. Bond angle, that is the angle between the atoms. I think we did it in the last class. This is the example. Bond angle will always be, see, when somebody asked me to mark the bond angle of ammonia, NH3, and it has a lone pair. Please remember, we always talk about this is the bond angle. Remember, for angle, you need to have two arms, right? Going back to mathematics, we have two arms and we have a corner. But if somebody says that he or she wants to have a H, N, or lone pair bond, no, not possible. Because this is only on the nitrogen atom. It has to be only H, N, H bond, which is of around 104 degree. Right? Please clear this doubt, because one of the sample papers which I got from CBSE for class 11th itself, they have drawn a pictorial image and asked you to pinpoint the bond angle of a certain unknown molecule. Like in mathematics, we say the angle will have 3 alphabets: A, B, C, CBA, X, Y, Z, PQR. Here also, the bond angle should involve 3 atoms, H, N, H. In case of water, it is HOH. That's the only important point or important takeaway from this particular slide, right? Then, bond enthalpy. Enthalpy word we have discussed many times. Enthalpy means it is an energy which is required. We have put how do we define bond enthalpy? It is the amount of energy required to break 1 mole. At the beginning of our classes, when we were doing chapter 1, we said mole is a counting unit for the scientist. So coming back to the same, what do you say? They don't talk about one or two bonds. They say amount of energy required to break 1 mole of bonds between 2 atoms of a gaseous state, right? If we have a molecule of hydrogen or homonuclear molecule. Homonuclear molecule means which have both the atoms similar. Then it can be easily calculated by just knowing the values. But if we have 2 different polyatomic molecules, they call it as, then we use the term as average bond energy, right? Average bond energy means that water, this is the classical example. Water dissociate into H plus and OH, right? And then OH minus dissociate into hydrogen and oxygen. So that means average energy means that you will be adding both of them and dividing them by 2. So bond enthalpy for we say molecules which are having only similar molecules, it will be the direct energy required to break 1 mole of bonds between the 2 atoms in gaseous state. But when we have a polyatomic molecule that is having different atoms, as in case of water molecule, then what we say, it will be considered as an average bond energy, which is required to break all the bonds of a molecule, right? So that's just an example is there. Now, have you heard about the term bond order? The bond order is number of bonds between 2 atoms. This is the bond order of H2 is 1. That of nitrogen is 3. Oxygen molecule is 2. The bond order, it indicates number of electron pairs shared. Number of electron pairs shared between 2 atoms. Right? So I think that is the next one. Yeah. Okay. Then this is important from the perspective of the question. Isoelectronic molecules and ions have identical bond orders, right? May be applicable to in your case also when you get such a complicated question. Bond order, I think it's towards the end of the chemical bonding. I believe you have been taught in your school about the bond order. Yes or no, Ritika?
No, mom.
But you said chemical bonding is coming in your test tomorrow.
Mom, I don't have a test tomorrow. Mine already got over on Monday.
Okay, sorry. Then Shweta and Ananya might have said that to me. Okay. Ananya, is it coming in your exam, the chemical bonding?
Yes, ma'am. I have chemistry exam tomorrow.
Yeah. So, do you agree to the statement shown here? That bond order and bond enthalpy are inversely related to each other? Can you explain it to me? See, out of sigma and pi bond, which one is supposed to be more stable, more energetic, which is difficult to break? We have understood sigma is a strong because area of overlap is high, right? For pi, we say the reverse. It is a weak bond because area of overlap is low, isn't it? But if you have to break, let's take any hypothetical molecule. Even if the double bond, the first bond is sigma, the second bond is pi, right? In any case, this pi bond will be requiring certain energy. If this one is sigma is requiring 100 joules, the pi will be requiring 25 joules at least, 1/4 of it. So what will happen? Overall energy required to break this molecule will be higher. Making sense? And more importantly, bond length will decrease with the double bond. It is as simple as that I have two flexible poles. If I join them with one rope, the possibility is they will not come closer. But if I join them with another rope also, what will happen? They will tend to come closer. Like sometimes while packing your lunch boxes, your mom must be adding certain more rubber bands to it so that it fixes. It doesn't open up and spoils your books and copies, etc. Right? So more the bond order, more will be bond enthalpy. That means that if bond length, if there are double bond, if C double bond C, C single bond C, C triple bond C, this one will be the shortest. Because even if, as I told you, even if the force is weaker, it is there, right? So what it will do? Stronger force, it will make atoms closer to each other. So this will be the shortest and this one will be the longest. So please remember this concept. May not be used directly today, but I'm talking about this chapter only. Overall, many reasoning questions. Say it can be as simple as talking about the reactivity of ethene and ethine. Which one will be more reactive? Since ethine has got 1 sigma and 2 pi bonds, more bonds, they come closer, more bond enthalpy and shorter bond length. Is it clear? Is it clear to all of? Okay, so let's do some questions quickly. This will probably benefit all of you, especially those who are having exam tomorrow. Arrange the following in the order of decreasing bond angles: methane, ammonia, water, boron trifluoride, and ethine. Now, can you quickly tell me the bond angle of methane? I think it was 4 electron pair, regular geometry, 109.28. Ammonia, as I told you, it has got 1 lone pair of electron. So that will be around 107. Water, approximately 105. BF3, remember the structure, boron trifluoride. What was the bond angle? 120. C2H2 was this, linear, bond angle 180. So, which one is what is the decreasing order? I believe this chapter is more about first understanding, then remembering. So please apply those things so that you are able to score in this chapter. And believe me, the second, third, and fourth chapter, that is a structure of atom, chemical bonding, and this structure of atom, periodic classification, and chemical bonding. They are the foundation of your chemistry syllabus of this year as well as the next year. I think we will skip this question because it's based on periodic table. Now, coming to this question. Carbon-carbon bond length is least in which case? See, for solving, I'm solving the question with you because I understand that the concepts are clear, but remembering and recalling them may take a certain time. So for C2H6, we can draw the structure like this, right? There is a carbon-carbon single bond. If I talk about C6H6, it is benzene, where we have alternate carbon-carbon double bond. Talking about C2H4, it has a double bond. And C2H2 has a carbon-carbon hydrogen bond. Sorry, carbon-carbon triple bond. As we have discussed just now, that more the number of bonds, smaller will be the bond length. So which will have the smallest bond length? To me, it has to be ethyne. Is it clear to all of you, Ritika, Ananya, Shweta, and others?
Yes, ma'am.
Okay. Now, bond order can't exceed any answer to this. Till now, we have seen only the triple bond, right? So what does that mean? Bond order cannot be more than 3. Had it been there, we would have talked about a compound having CC4 bonds also. So that's just a logical representation for you to, at times the questions may be very stupid or very logical. I classify this question in that because the teacher has taught you only 3. And think logically, carbon is the boss of every element. So it should not be forming more than that. Now, then we will have to start the next topic, that was resonance. Do you have any idea about what is resonance? Or when do we use the concept of resonance? Any idea, Shweta?
Can you repeat the question, please?
What is resonance? See, in bond parameters, we have discussed bond length, bond angle, bond enthalpy, bond order. We are left with these 2. So I was just asking, do you have any idea what is resonance, or is it being taught in your school? Because some of the teachers prefer to teach it along with a certain other chapter of book 2.
No, I don't know.
I didn't
Not
get you.
sure.
So
I'm not sure. Yeah.
Okay, what about Ananya and Ritika?
We haven't learned it.
You haven't. Ritika, you? No idea? I'll just give you a brief introduction of what is resonance. See, whatever we say, whatever said and done has a scientific base. When we say that ethene has a double bond, we say it on the basis of certain presumptions, certain observations. Then these observations have to be met out correctly. We have a test for the compound having a double bond. Like in class 10, you have heard about the ester test. When you say that when carboxylic acid and alcohol are mixed, they produce a sweet smelling esters. Similarly, all the alkane, alkene and alkynes are by and large colorless. Now, if I have to know whether this compound has a double bond or a triple bond, or it does not have any type of a carbon atom, we can perform one test. We say we will be adding potassium permanganate, KMnO4. This KMnO4 is a purple colored liquid. And if it is added to ethene or any other alkene, what happens? It decolorizes. The technical word we use here is decolorizes. Decolorization. That is, the color disappears. So if someone from your class gives me a colorless liquid and says, ma'am, it is ethene, I will say, take a small part of it and add potassium permanganate into it, get it from your laboratory and add to it. If the color disappears, I'll believe that you are correct. It is ethene. And if it does not disappear, I will not believe it, right? Now that happened with benzene. The scientist assigned benzene this structure as we have drawn it, right? They say it has alternate carbon-carbon, double and single bond, and then it has 6 hydrogen atoms. So since it has 3 double bonds, it must decolorize the potassium permanganate, or we call it as alkaline solution as Bayer's reagent. Alkaline KMnO4 means that KMnO4 is dissolved in KOH. Right? So that means if I add this alkaline solution of KMnO4, which is commonly known as in the scientific field as Bayer's reagent. If I add to it, that means the color must disappear, right? But it does not happen. The color remains same, right? So therefore, scientists say its structure is either not correct or we are missing out something. Then they introduced the concept of resonance, where they said when the properties of a substance cannot be explained by one structure, it is said to be a mixture of many structures. Say, for example, I am Dr. Shikha Mishra. One of my faces or one of my personalities when I'm teaching to you. One of the other personality which I have, maybe when I'm talking to my daughters. The other one can be when I'm talking to my, say, in-laws. Other one can be when I'm going for a walk and just talking to my neighbor. But I am one. Similarly, they say that the compound may have more than one structure, right? It's like a role play. But the real structure will be in between them. What you are seeing me as a part of my personality, my own persona. Similarly, the structure which we have drawn here is a part of it. It is correct. but it may have many other faces. Like I have many other faces, other roles in my life to play. They collectively make me Dr. Shikha Mishra, right? Similarly, there are certain compounds whose all properties cannot be explained assuming it to be a single structure. There we apply the concept of resonance, right? So for the rest of the details, we will do it in the next class on Monday. And till then, whosoever is having that exams, all the best to you and do well. And please revise all the subjects, not only chemistry. Chemistry, especially as I am again repeating myself, chapter number 2, 3, 4 are very critical, right? So with that, I wish to end the class. Have a good day.
Thank you, ma'am.
Welcome.
Thank you, ma'am.
Welcome.